Hey guys, welcome to my channel. Our topic is hydrostatic pressure. I will discuss here how to calculate the hydrostatic pressure and its meaning. This is for the beginners, especially the roustabouts and floorman, to have a good understanding and basic pressure, and also for those who wants to enter in the drilling industry. Okay, first, what is the meaning of hydrostatic pressure? The pressure exerted by a column of fluid at rest at a specific depth in that fluid. You will see in the drawing. The pressure exerted by a weight of fluid in any given point. I will show you an example of hydrostatic pressure. If submarine dives below the surface, the pressure on the hull will increase. This is because the height, and therefore the weight of water above the hull increases, so exerting a greater pressure. The deeper the submarine dives, the higher the pressure on the hull will increase. This is the formula of hydrostatic pressure. Hydrostatic pressure is equal to mud weight times the constant 0.052 times the TVD or the depth. As you can see here in the formula, hydrostatic pressure will depend only on mud weight and TVD. And guys, this is static. This formula is for static, meaning the well is not circulating. Because if the well is circulating or moving the fluids, we will add here an APL, the annular pressure loss. So we will focus only on the static. So we will erase first here, this one, static. By the way guys, this formula is in English system. I will write here the formula in metric system. You can see the difference in the formula. Here is the PSI, bar, ppg, kilogram per cubic meter, and their constant, feet, and the meter. In the oil field, in drilling industry, this is the most used formula. So we will disregard this first, and we will focus on the system English. I have an example here: well A, well B, well C. So in well A, the depth of well A is 8,000 feet and 9.0 ppg, and the diameter of the hole is 12.5. In well B, 8,500 feet and 12.5 diameter. In well C, we have 16 inches to 12 inches to 10.5 inches, and they have the same mud weight, 9.0 ppg. The question is, which of these three wells has a higher hydrostatic pressure? Well A, well B, or well C? The answer is they have the same hydrostatic pressure. Why? Because they have the same mud weight, 9 ppg, 9.0 ppg, 9.0 ppg, and they have the same depth, the 8,000 feet. Also here, 8,000 feet. And the well C have also 8,000 feet. It will not depend on the measured depth, just like this. It will depend only on true vertical depth, the 8,000. That's why they have the same hydrostatic pressure. I have another example here, the effect of depth. Imagine a tall container full of water. In container 1, if we make a hole in the side of the container, the water will come out. In container 2, if the hole had been made farther down the container, the water from this hole will be forced out a greater distance, as you can see here. In container 3, a hole even farther down shows the water forced out even greater distance. You will see the difference. Okay. I have an example here how to calculate the hydrostatic pressure. Calculate the hydrostatic pressure exerted by 12 ppg mud in a well with a true vertical depth of 8,500 feet. So our formula is hydrostatic pressure equals to mud weight times the constant 0.052 times true vertical depth. The mud weight is 12 ppg, 12.0 ppg times 0.052 times the depth 8,500 feet. So the hydrostatic pressure is 5,304 psi. Let's talk about formation pressure. Formation pressure is the pressure exerted by the fluids in the pore spaces of a formation. As you can see in the drawing, this is the hydrostatic pressure, the formation pressure. As I have said before, there is a force here exerted by the weight of fluid into the well bore, and also the fluid in this formation will exert a force into the well bore. That's why we need to balance these two pressures to prevent the kick. So I have a question for you guys. Is there a pressure gauge or formation pressure in the driller's cabin? What do you think, guys? The answer is no. So how would they know the formation pressure? MWD and LWD use tools to gather data that can predict formation pressure. And to prevent overbalance and underbalance of the well, they perform break-off test, which is LOT, which means to estimate the maximum pressure or the mud weight that the test point can withstand before formation breakdown or fractures occur. That's why they can balance the well during drilling. Alright, and the last is the concept of balance. Mud hydrostatic is used to control formation pressure. That is, mud hydrostatic must be sufficient to keep the formation fluid in the formation and not allow any into the wellbore. The difference between the formation pressure and bottom hole hydrostatic pressure is differential pressure. These are classified as overbalance, underbalance, balance. Overbalance means the hydrostatic pressure exerted on the bottom of the hole is greater than the formation pressure, as you can see in the drawing. Here in the underbalance means the hydrostatic pressure exerted on the bottom of the hole is less than the formation pressure. And the last is balance. Means the hydrostatic pressure exerted on the bottom of the hole is equal to the formation pressure. You see the picture? That will happen in your well if there's overbalance and underbalance. The well should always balance. There are two main opposing pressure in a well. There are the fluid column hydrostatic pressure and the formation pressure. If one pressure overcomes the other, then a kick or loss circulation may occur. Since hydrostatic pressure is a function of the density of the working fluid in the well, its value may be controlled by making careful calculations and by manipulating the formula for hydrostatic pressure. It is possible to test cement jobs to estimate formation integrity, to project maximum mud weights, and to control kicking wells. And to the beginners in drilling industry, you better to understand this.